First one, growth or decay? Growth. Y-intercept? 0, 1, yep. Okay, so it's going to go like that. Okay. Two key ones, or the 2 key points, would be at 0, 1, and at 1, 3. Alright. Horizontal asymptote. Y equals 0. Second one, growth or decay? Decay, because it's decreasing, or it's b is less than 1. Okay. Oh no. Oh, come on now. Why is getting all once in a while I get all funky with it. Oh well. So 0, 1 and 1 comma half. It's gonna come down. Okay. Number 4. Growth or decay?
Growth.
Growth. Yes. Okay. Horizontal asymptote got shifted up to 1 is going to be where the exponent is 0.
Is that going to be 2 then?
That's going to be 2 then, yep.
Oh, wait. Wait. No, it's going to be 3?
It's going to be 3, excuse me, yes.
Alright.
Nope. That was my bad, I agreed with you. Yep. And then the next easiest one would probably be 2. Because you got 4/3 then plus 2 is 10/3. Don't know. You did get 11/4 if you went to negative.
Yeah, that's it.
Or excuse me, to 0.
Yeah, 0, 11/4.
Yep. Alright, awesome. Love it. Alright, let's talk the third page then in that wonderful passage. Let's talk about base E. The exponential function, base E. 2.7182818 something. One of those like pi that goes on forever and ever and ever. Okay. In higher levels of mathematics, the base E is primarily used in exponential growth and decay situation because it's so much easier. Base E is so much easier. You have a positive exponent, it's a growth. You have a negative exponent, it's a decay. That's what makes it so much easier. Okay? It's not, well, B is 7 ace, and is 7 ace positive, above 1 or below 1? It's not like that. It's straight up, if it's positive, it grows. If it's negative, it decays. Okay? Number E came into importance in the 1600s with Napier's work on logs, as well as Bernoulli's work on continuous compounded interest. A bunch of other people stumbled upon it too. Okay? So, our function, f of x equals e to the x. So if e here is if e is 2.71, okay? So if we think back to yesterday, is that going to be f of x equals e to the x? Is that going to be a growth function, or is that going to be a decay function? Growth. Growth, because our b is bigger than 1 from yesterday. Will it ever go negative?
No.
No, because it's a positive number, right? Always being taken to the next. So that means y equals 0. Still working on that.
What if you did -1 at the end point?
What about it?
Couldn't it be all?
It would be positive. It would be 1 over 2.7, so it'd be like 0.34 or something like that. Okay. What's my y-intercept?
0, 1.
Yep, got 1. And then we got 1 comma e. Okay. E is constant. How do we change the rate? Here, growth of the function? Okay. Well, let's explore it. Okay. So exponential functions that use base e have a general form of a times e to the kx power, where the rate of growth or decay is controlled by the variable k. Okay. So I'm just going to flat out tell you that actually, or I have already told you that if k is greater than 0, she grows. Okay. We'd be in growth. If k is less than 0, she decays. Now, I've told you those truths to be self-evident. Pretty much. Okay? You tell me why that makes sense. What do you mean?
K is like the first power that E takes on.
You think what? What do you got?
Because E is a positive number that's greater than 1, so it's opposite. Reciprocal is going to be a fraction that's less than 1.
Okay. Okay. I would agree with that. Yeah. Like that? Is that what you're trying to say, Joe? Mm-hmm. Right? And then this would all be to the k power down there. So if it's negative, k is negative, it's exponentially growing. It's just exponentially growing in the denominator. Whereas if k is positive, it's exponentially growing in the numerator, which is the difference between growth and decay. Okay. Fractional exponential logic. Okay. So let's compare the two. Yesterday, today. Oops, wrong way. Nope, I was right. B is bigger than 1. Makes it grow. Do we agree? For yesterday? A greater than 0. Yep, because it can't have a negative. Today, we get that. Okay. Word me. I like words. My exponential growth is of the form f of x equals a times b of x. Then the rate of growth or decay is controlled by the value of b. If b, now we need words here, wordages. If b
Greater than 1.
is bigger than 1 or greater than 1, then the function has exponential growth. Yep. And if b is, we say even cleaner. Between 0, can we go 0 and 1? Then we're going small space. Then we have exponential decay. If my exponential function is of the form f of x equals a times e to the kx power, and the rate of growth or decay is controlled by the value of k. If k is positive, so we say it's positive, then the function has exponential growth. And if k is negative, then the function has exponential growth. Okay. So, put it to work. First one. F of x equals 4 times e to the 0.5x. Okay? Do we have a d value like we had one yesterday? No. So what does that mean? Horizontal asymptote is still at y equals 0. Okay? That's a good thing. So let's put that on there first. What do we think about yesterday when we were graphing? We graphed just 2 points, right? Yeah. Okay. What is the one x value that's going to give me 0 for my x point? 0. Okay. Let's grab 0. Point 0.5 times 0? 0. E to the 0. 1 times 4. 4. So this one's just 0, comma, 4. What is the x value that's going to give me an exponent of 1? 2. 0.5 times 2? 1. E to the first. 2.7, let's call it. Let's just call it 2.7. We'll approximate. 2.7 times 4.
Ten point one.
About 10.8.
All
Times 4, right? 10.8? 2.7? 10.8? Does that fit our model? Because this is a growth, right? Right?
Yeah.
Does that fit the growth model?
Yeah.
Yep. Like it. Okay. You graph example number 2. All right. So let's start slow. First off, growth or decay. Decay. No, not you would think. It's a decay. Because it's got a negative pickup. Yeah. Okay. Horizontal asymptote. Y equals 1. X value that's going to give me 0. 0. E to the 0 power? 1 times 14. 14 plus 1. 15. Next nicest one. 0.5?
Would it be negative 0.5?
You're negative. Yeah, negative 1.
Negative 0.5 to make it a positive 1? Okay, right? Negative 0.5. Then you get like 40.2, right?
Yeah.
Okay? Which would be there. Does that still fit our decay? Yeah. Okay. What if we didn't like this because it's such a big number? So what if we go with positive 1? Correct.
Then we have to put E.
No? No? Okay. We're just kind of estimating, right? So it'd be negative 2 up top, right? So that's e to the negative 2 power, right? Which so it's basically it's 14 divided by e squared.
Yeah.
Now e is close to what?
3.
Close to 3, right? Right? Okay. So 3 squared is 9. Okay. So 14 divided by 9 is what?
1.5.
1.5-ish, let's say. Okay. Right? Plus 1. 2.5.
What do you stop the points if we write ish? So the approximate. Still inspired?
What's up?
If we write ish instead of approximate signs, what would we dock?
Why would I dock you points on this?
No, like if we did it on
No, like, why would I dock you points on this?
Because it's 2.5-ish, not
But why would I, but right? It's, what would I be grading on this one? that you understand that it's a decay and that you can find a couple of points, right? This was just an extra point that we found,
Okay.
all right?
So if you find coefficient. Oh.
Because it's really not 2.5. Because we rounded E to 3. So we're off right from the start. Okay? We just wanted to get an approximate so we could see that it followed our decay value. Yes, indeed we do. Love it. That's all I got for you.
Wow.